Hello everyone, in this video we're going to be solving a quick and easy factorial equation. We have m factorial equals 120 times n factorial. I know the thumbnail didn't show the multiplication sign, but hopefully you got that. So we are looking for m and n values where m and n are both integers and they're supposed to be non-negative integers. So we also have factorials for negative numbers, for real numbers. In general, using gamma function, you can write the factorial of pretty much any number and find it, hopefully. There's an integral definition of the gamma function, which you can find online, and I'll try to share some links down below as well. Anyways, but we're looking for basic integer, non-negative integer solutions. Okay, great. So let's get started. We have m factorial on the left-hand side and an n factorial on the right-hand side. So they're both factorials, and factorials are kind of interesting. Let me briefly talk about factorials. So basically, factorials are loosely defined as the product of consecutive integers that start with the 1 and end with the number that is being factorialed. I don't know if that's a word, but think about it this way. Like if I have 4 factorial, that's going to be 1 times 2 times 3 times 4, and yeah, I have to stop at 4. Some people write it as 4 times 3 times 2 times 1 because it's good for some reason, I'll tell you, but 4 factorial would be 24. Or 3 factorial would just be 3 times 2 times 1, and the reason why we write it that way is because if you think about it, 2 times 1 is also can be written as 2 factorial, so 3 times 2 factorial is 3 factorial. So larger factorials contain the smaller ones, so when you look at this equation from that perspective, it makes more sense. So we can safely say that m is going to be greater than n. Okay, great. So not only that though, 120 is also a special number. Let's talk about 5 factorial, for example. That's going to be 5, 4, 3, 2, and 1. And if you multiply these together, obviously this is 1 factorial, this is 2 factorial, this is 3 factorial, this is 4 factorial. Notice that each factorial contains the other ones, the smaller ones, and 5 factorial basically contains all the factorials that are less than or equal to 5 factorial. So what does that mean? Well, if you multiply these out, you're going to find that 5 factorial is 120. Does that matter? It does, because we have 120 in our equation, and that just happens to be 5 factorial. It's going to help us a lot, but let's go ahead and look at the simpler cases first. So we have m factorial equals 120 times n factorial. Great. I think we've done a similar problem before. I can't remember exactly when. You guys are better at finding those links. But anyways, if I do find it, I'll share with you. So let's start with something that should be a little, I think, more obvious maybe. So here's what it is. Remember, we said that 5 factorial contains 4 factorials. How is that possible? Well, 5 factorial can be written as 5, 4, 3, 2, 1, but 4, 3, 2, 1 can be written as 4 factorial. So we can basically replace 5 with 5 times 4 factorial. And that's exactly something that we have here. Look at this. An integer multiplied by a factorial becomes another factorial, as long as these two numbers are consecutive. Exactly. So these two are consecutive, like 7 times 6 factorial is 7 factorial, 99 times 98 factorial is 99 factorial, so on and so forth. You can write lots of examples. But in this case, I want n to be 119 because 120 factorial is 120 times 119 factorial. So it just fits the pattern. N equals 119 is a solution. It's just one of the solutions, but there's more. Remember what we said about the number 120? We said that it's 5 factorial. So how is that going to help us? Let's see. So when we write this equation and replace 120 with 5 factorial. Now here's a good question. And I believe I've done a problem on that one too. Can the product of 2 factorials be another factorial? Yes. There is a very special situation, and I believe that was 10 factorial equals 7 factorial times 6 factorial, because 6 factorial is 720, and 720 happens to be 10 times 9 times 8. When you multiply by this, it just becomes 10 factorial. But that's a very special scenario, and I don't think there's any other case like that. I could be wrong. Please correct me if I'm wrong. But I think that's unique. So we can't really get a nice solution from here, but we can get some solutions that are not that nice. They're actually nice, but here's the thing. We're going to find a cheap solution, because if this is equal to 1, then m factorial equals 5 factorial obviously has a solution, don't you think? Because m is going to be 5 in that case. Yay! But does n factorial equal 1 have a solution? And the answer is yes. It actually has two solutions. N could be 0 or n could be 1. I know we did not talk about this at the very beginning, but when we said, okay, 1 factorial is just 1, 2 factorial is 2 times 1, which is 2, 0 factorial is just 1. Why? Because you're not multiplying by anything, and when you don't multiply by anything, there's always 1 in the product. That's why it's 1. You can also kind of talk about it in an equation like this. You know, we can write n factorial as n times n minus 1 factorial, and if you replace n with 1 on both sides, you get 1 factorial equals 1 times 0 factorial. This is 1, so 0 factorial must be 1. Okay, this is kind of like a cheap proof, but there's probably other proofs that will tell you that this is true. So 0 factorial is 1. Oh, you can also look at it from a permutation perspective. N factorial is basically number of ways you can arrange n objects, and if you have no objects to arrange, there's only one way to arrange them. You just don't arrange them, and that's 1. When you have one object, you just put it there. That's it. So that's kind of interesting. It's kind of like an empty set, because empty set has no elements, but that's one of the subsets. Okay, that's why we get that 2 to the power n formula. Otherwise, without the empty set, it's going to be 2 to the power n minus 1. Anyways, those are different topics. I digress, but I just want to get back to this. So what was our conclusion? Yes, n factorial. If n factorial is equal to 1, then we got a solution, and that gives us n equals 0 and n equals 1. So let's write the conclusion, and we'll finish up with that. So m factorial equals 120 multiplied by n factorial has the following solutions. Okay, we're going to write them as ordered pairs, and allow me to write m comma n alphabetically, correct? So if m is 120, n is going to be 119. Remember the very first case scenario we looked at. If m is 5, then n is going to be 0, or n is going to be 1. Because remember, those are the two solutions that we got by setting n factorial equals 1, and obviously that means m is equal to 5, because if m factorial is 5 factorial, then m is equal to 5. And this brings us to the end of this video. Thank you for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you next time with another video. Until then, be safe, take care, and bye-bye.